Well, hello and welcome to today's lecture. So we're going to start chapter 6. We're going to talk about confidence interval. So chapter 6, 6.1, what are the objectives? Objectives are finding the point estimate. So point estimate. And finally, use that point estimate to actually construct a confidence interval or a range of estimates. Construct a confidence interval. Very well. So we learned that when we try to estimate the population parameter, like the mean of the population, using just one sample, actually our chance is very low. So suppose you have a population and you're trying to estimate the mean of the population. If you take just one random sample, and find the mean of your random sample, the chance that X bar and mu are the same is very low. Very well. So to increase our chance to capture the population parameters, in this case the population mean, we're using confidence interval. Very well. We have to follow some steps to construct a confidence interval, and these are the steps. The very first step is to check to see if n, or the sample size, is greater than or equals to 30, or if this condition is not met, you need to check to see the population is normally distributed, or population is normally distributed. Next step, in step 2, we need to find our point estimate. Since you are working with the population mean, the unbiased point estimate is sample mean. Sample mean, or X bar. Very well. In the next step, you're going to identify your level of confidence. Level of confidence. What is level of confidence? A level of confidence is actually the level of confidence, or C, is actually just a measure of degree of reliability. Level of confidence is a measure of degree of reliability. When it comes to statistics, we usually work with 90%, 95%, or 99% level of confidence. These are popular level of confidence in statistics. So 90%, 99%, and 95%. Question? Yes, very well. We can say that C, or level of confidence, is actually the probability that the interval, the confidence interval, contains the population parameter. So C is the probability that the confidence interval contains the population parameter. Very well. After identifying the level of confidence, the next step is to actually find the critical values. Step 4, critical values that we denote it right plus minus z sub c. Plus minus z sub c. So level of confidence as a probability, you have your probability. Your next step is to find your z values, inverse norm. So by using your z table or inverse norm. I'll show you. You have to subtract the level of confidence from 100% or 1 divided by 2. We're going to go over example. After finding the critical values plus minus, remember that since we have a normal distribution and we have 90% or 95% or 99% level of confidence, it means that we have symmetry. Because of symmetry, so here suppose you have 90% probability or confidence level. So it means that 1 minus 90% is equal to 10%. 10% is divided into 2 areas, on the left, on the right. So these 2 areas are exactly the same. Exactly the same. So we have 10%, 10% divided by 2, 5%, 10% divided by 2, 5%. Very well. To find critical values, here remember that on the left-hand side of 0, you get negative z values. On the right-hand side of 0, you get positive z values. Okay, here you can either use your table or you can use inverse norm to find critical values. Let me show you. So let's take a look at our calculator to actually find the critical values. So here you have C, the confidence level, which is 90%. Here we have a normal distribution, standard normal distribution, so 0. And here you have 90%. Suppose the 90% is here. Okay, so 1 minus 90%, 1 minus 90%, or 100% minus 90% is 10%. We divide 10% into 2 equal areas. So 10% divided by 2, 0.05. 10% divided by 2, 0.05. Now to find this z value, negative cc, we're going to use our calculator, inverse norm. So second verse, inverse norm. So here we have the area, the probability, which is 5%, and the mean is 0, standard deviation is 1. So enter, enter. And here we have negative 1.645. Because of symmetry, this number on the right-hand side is positive 1.645. So these z values or critical values are actually separating the rejection region and non-rejection region. So when C is equal to 90%, ZC, negative ZC, is equal to negative 1.645, and positive CC or critical value is 1.6. How about 95%? Take a look at 95%. So C is 95%. Here we have standard normal distribution. 0, 95%. 1 minus 95% gives you 5%. So now we're dividing 5% into 2 equal areas. So 5% divided by 2, 5% divided by 2 gives you 0.025. 0.025. So what is the z value? To find this z value, the critical value on the left-hand side, negative ZC using inverse norm. Inverse norm, 0.025. Standard deviation is 1, mean is 0, and enter, enter. You get negative 1.96. And because of symmetry, your positive critical value is 1.96. Negative ZC, negative 1.96, and positive ZC is positive 1.96. And finally, if we have 99% level of confidence, let's take a look at our calculator. Standard normal distribution, mean is 0, so C is 99%. 1 minus C is equal to just 0.1%. This is a very small area, so here you have 99%, and here you have 1% divided by 2, 1% divided by 2. Zero point 0.005 and 0.005. Very well, as you can see, these two areas for probabilities are very small. So let us find out negative ZC, positive ZC. So let us go to second vars, inverse norm, 0.005, negative 2.575, and positive 2.575. Negative ZC, negative 2.575, and positive critical value 2.57 and 5. So you either memorize these critical values, or you can always get back to your calculator, use inverse norm, or if you're using your Z table, you can find these values using your table. So what are critical values? Critical values are actually values that separates probable sample estimates. So values are values that separate the sample estimates that are actually probable from unusual ones. The sample estimates that are probable from improbable or unusual one. Improbable or unusual one. Or you can say that, hey, this separates rejection region from non-rejection region. We're going to talk about it when we are talking about the hypothesis testing. So in our next step, step 5, we need to find the margin of error. margin of error E, which is defined as positive critical value, ZC, times sigma divided by square root of n. Sigma is the population standard deviation, and n is actually your sample size. So what is margin of error? Margin of error actually, let me find my eraser. So margin of error actually gives you the maximum distance or largest distance between your point estimate and your population parameter. So margin of error it is the possible maximum distance between points estimate and the population parameter value. Very well. And finally, the last step, step 5. Now we have step 6. The mean, in this case, remember that we are trying to estimate the mean of the population. The mean is going to be in between the mean of the sample plus margin of error and the mean of the sample minus the margin of error. So we're trying to construct the confidence interval. Our confidence interval, it has lower bound, which is x bar minus margin of error, comma, x bar plus margin of error. This is your confidence interval. Any question? Well, on page 3, let us go over one example to feel comfortable about these steps. Page 3. So in page 3, it says, let me erase that. Page 3 says, use the data in example page 1 to construct 95% confidence interval for the mean number of hours worked by grocery store employees, and assume that the population standard deviation is actually 7.9. So what information are given to us? Remember that from example 1, we had n, or the sample size equals to 40, and the mean that we actually calculated was 29. 0.6 minutes. Yes, perfect. 29.6 minutes. Confidence level is given. C is 95%. And standard deviation of population is also given 7.9. What is the confidence interval? So, in this example, we have the following information. You know, n is equal to 40, x bar 29.6 minutes, sigma is equal to 7.9. The question in chat. Sigma is 7.9. Confidence level is 95%. So we have to follow these steps. Step 1, sample size. So in step 1, the sample size is equal to 40. Is 40 greater than or equals to 30? Yes. So the first condition is met. We're good with the first step. We're moving on to the second step. Step 2. What is the sample mean? Sample mean, X bar, we calculated that. It is equal to 29.6. In step 3, what is the level of confidence? C is equal to 95%. It's given to us. Step 4, we need to find our critical values, plus minus ZC. So you either use your inverse norm, or you know that for level of confidence, 95%, the critical values are equal to plus minus 1.96. So negative ZC, negative 1.96, and positive ZC is 1.96. Any questions so far? Very well. In our next step, step 5, what do we have? We have the margin of error. E is equal to positive ZC, 1.96, times sigma. What is sigma? Sigma, or the population standard deviation, is also given to us, 7.9, divided by square root of, what is n? N is equal to 40, sample size. So let us do the calculation. So the margin of error is approximately 2.4. And in the last step, step 6, let us construct our confidence interval. Mean of the population is in between X bar, which is 29.6, minus E, 2.4, and X bar, which is 29.6, plus the margin of error, which is 2.4. So your mean is in between. Question? Yes, we add, we subtract. So here you have 32, and if you subtract these two, 27.2 and 32. Or you can write down the confidence interval equals to 27.2, comma, 32. So what's the meaning of that? You say that with 95% confidence, with 95% confidence, the population, so we're talking about the population mean hours worked in the store is in between 27.2 and 32 hours. The population, when you're talking about, you're trying to estimate the population mean. Population mean time worked in the store is between 27.2 and 32 hours. So how do we use our calculator? Let us take a look at our calculator to construct the confidence interval. So to construct the confidence interval, you go to stat, you need to go to tests and find Z interval. Enter. You have data and you have your stats. Stats, enter. Sigma, which is your population standard deviation, is 7.9. X bar, or the point estimate, which is 29.6. The sample size, it was 40. And the confidence level is 95%. Well, let us calculate that. So the confidence interval by using your calculator is 27 point. So if you round this, 0.2, comma, 32. The mean is in between 27.2 and 32. Any question? Please take your time. Write this down. Let us move on to the next example. So let me erase the board. On page 4. So let me write down the instruction how to use your calculator. So calculator, you go to stat. And you go to test. You find the Z interval. Go to stats. Enter the information that you have. There you go. So let's write down the instruction how to use the calculator. So we go to stat. Then we go to tests. Now you need to find the Z interval. Z interval. The next step, you need to enter the data in stats. In stats. There you go. In stats, you need to specify the sample standard deviation, sigma, and X bar, the mean of the sample, and the sample size, and confidence level. Then calculate. Let us move on to the next example. So we are on page 4. Example. On page 4, we're constructing a confidence interval. A college admissions director wishes to estimate the mean age of all students currently enrolled in a random sample of 20 students. So what is this 20? What do you think, everyone? Yes, sir, very good. That's true, it is 20. N, or the sample size, is equal to 20. The mean age is found to be 22.9 years. What does this mean? Is this the mean of the population, or is this the mean of your sample? Take a look at this. The starting of this sentences in a random sample. The mean is 22.9. So your X bar is given. The rest of the information. From past studies, the standard deviation is known to be 1.5 years. Standard deviation of your population. So sigma is also given to you, 1.5 years. And the population is normally distributed. Population is normally distributed. Question says, find and construct a 90% confidence interval for population mean. Very well. Let us identify and write down the information that we have. N for the sample size is equal to 20. X bar is also given to us. X bar is 22.9. Sigma or the population standard deviation is given. Sigma is 1.5. We also have confidence level, which is 90%. 90%. Very well. So we have to check all of these steps, step by step. Step 1 says your sample size is greater than equals to 30. Our sample size is 20. 20 is not greater than equals to 30. Or the population is normally distributed. Take a look at your question. The population is normally distributed. So the second condition in step 1, which says, or population is normally distributed, is met. Okay, so we're not worried about this case here. Population is normally distributed. Very well. Step 2, find sample mean. Sample mean is also given to us. X bar is 22.9. Level of confidence. What is the level of confidence? 90%. So step 3, 90% level of confidence is also given. So we can either use our inverse norm or use our z-table, or if you have your critical values written on your note, you know that ZC plus minus the negative ZC, positive ZC, these values are equal to, so you have 1.645 and negative 1.645. Very well. Question in the chat? Yes. Yes, you can use that. Very well. You can either use your z-table or inverse norm. Very well. So step 5. And step 5, what do we have? We need to form our distance, the margin of error. Margin of error is ZC, positive ZC, 1.645 times sigma. Sigma is 1.5 divided by square root of 20. Let us do the calculation. Okay. So margin of error is almost 0.6. Almost 0.6. Now that you have your margin of error, you can construct your confidence interval. This is our last step, step 6. So mu is in between x bar 22.9 plus margin of error 0.6 and 22.9 minus margin of error, which is 0.6. Very well. Your mean, the population mean, is in between 22.3 and 22. So you're adding these 23.5 and 22.3. So our confidence interval can be written as 22.3, the lower bound, and 23.5, the upper bound. So what's the meaning of that? It means that with 90% confidence, the mean age, what we're looking for, the mean age of all students, the mean age of all students is between 22.3 and 23.5. And 23.5. Well done. Let's take a look at our calculator. So we go to stat, let's turn on the calculator, let me clear the whole thing. We go to stat, we go to tests, and we find Z interval. Very well, we need stats. And so sigma is 1.5. X bar is given to us 22.9. 22.9. N is equal to 20. We're not worried about that because we know that our population is normally distributed and the confidence level is 90%. So enter, enter. As you can see, you get 22.3 and 23.5. If you round this,